Hello to all. Myself, Dr. Devashish Jha, Assistant Professor, Department of Computers and Department of Electronics and Communication Engineering from Madanapalle Institute of Technology and Science. Today, I will be discussing the topic related to the introduction to signal and system. And in this, we will be discussing. These are the topic that we will be discussing. First of all, we will see what is a signal. After this, what is continuous time signal and what is discrete time signal. Next will be how many types of elementary signals are there, what are those, we will learn that one. After this, we will study about the basic operation on signals. What are the some of the basic operation that we will study, and in the last, if any queries you will have, you can ask me. So let us start with this topic. And okay, so first of all, let us understand what is a signal. In this signal and system, we frequently encounter with what is a signal. In daily life also, you might be hearing that what is a signal, what is all about the signal. Okay, so a simple definition of signal is that a physical quantity that varies with time, space, or any other independent variable and have some information. It means a signal is a physical quantity that varies with time, space, and or any other independent variable and having some information. Means a signal must have some information. Like a as for the example, we can understand that the AC power supply. Okay, from the AC power supply is a signal. Like speech, what I'm speaking, this is a audio signal. It is reaching to you. Okay, so this is a signal, it is conveying some information, so this is a signal. Likewise, ECG, what is ECG? Electrocardiogram. ECG is sending the heart condition of a patient, so it is also a signal. It is having some information, and all these quantities are varying with some of the with the some time or space. Like AC power supply, it is varying with time. Okay, so anything with varies with time, space, or any other independent variable are and having some information is called a signal. Like another type of signal we can know that voltage. Yes, voltage is having some information. Like we say that this battery has providing 25 volt, it means it has some information, so this is a signal. Now come to next, what is a signal modeling, and why we study the signal modeling. So a signal modeling is representation of signals by mathematical expression is known as signal modeling. Why we need the signal modeling? The answer is that to analyze the signal with the help of mathematics, we can easily analyze the signal, or we can easily assess the behavior of the signal. So that's why signal modeling is important. So in the summarized form, what we can say that a signal modeling is nothing but the mathematical representation of any signal. Like uh, we can represent a sinusoidal signal or AC wave with the help of sine and cosine. So that is the mathematical expression is modeling of the AC wave. Okay, we can represent simple harmonic motion of simple pendulum with the sum to the mathematical equation. So that mathematical equation is nothing but the modeling of that motion of the simple pendulum. Okay, so that is about the signal modeling. It means whatever we are representing in the terms of mathematics, the behavior of anything, any signal that we are representing with the help of mathematics is called signal modeling. So hope this you have understood this. Now the next. Okay. Now, basically, we will study here how many types of signals are there. Okay, so there are basically two types of signal. First one is continuous time signal. Okay, and second one is discrete time signal. So, what is difference between continuous time signal and discrete time signal? So, first of all, we will see what is a continuous time signal. So, a continuous time signal is that type of signal which is defined at all value of time. To understand this, uh, let us okay. Now let us see here. This is a sinusoidal waveform. Okay, so you can see this waveform is defined at every time instant, at all value of time instant. Okay, so this is an example of continuous time signal because it is having the values at every instant of time. So this is called a continuous time signal. Okay, now let us understand what is a discrete time signal. So to understand the discrete time signal, what is definition first? So a discrete time signal is that type of signal which is defined at discrete instant of time. Okay, so how we can understand the graphically this the discrete time of signal? Let us draw here. So suppose this n equal to 1, 2, 3. Okay, so you can see here at this value we can see at discrete time instant. These values are not defined at all values of time. Okay, so this type of signal is called the discrete time signal because it is defined at discrete time instant but not all the time instant. Whereas uh, like a sinusoidal AC waveform, it is defined at every time instant. You can see here that at all the time instant these are defined. So this is the basically difference between a continuous time signal and discrete time signal. I hope that you have understood it clearly. Now, next we will understand the elementary signal. Okay, so there are some basic type of signal which are used many times in the any type of problems or anywhere. You will see this type of signal very frequently. So you should know what is the elementary signal and how many types of signals are there. So first of all, the basic signal is unit step signal. So what is a unit step signal? Unit step signal is defined as ut equal to 1 for t equal to greater than equal to 0, or it will be 0 for the negative value of time. Okay, so how to understand this? Let us understand what is this. Okay, suppose the magnitude is 1. Okay, and here is time. So you can see this unit step is defined only at positive time instants, but it is not defined at negative time instant, or its value is 0 at all the values that is negative, or at all the values of time that is negative. So this is a unit step function. Why we call the unit step function? So reason for this is that its magnitude is 1. Okay, you can see the magnitude is 1 and it is defined at every instant of time. So what is type of signal is this? This is a continuous type of signal. Okay, and this is the continuous time of signal. In the same manner, we can also uh, draw the discrete time signal, discrete unit step signal like this. Okay, so you can see this is the unit step signal in the discrete time domain. Okay, uh, it will not define at negative time instants. Now second one is unit ramp function. So what is unit ramp function? So unit ramp function can be defined as t when t is greater than equal to 0, or 0 when t is lesser than 0. So how we can understand by the figure? If we will plot this, okay, let us erase this. So here r of t, this t. So this is the pictorial representation of a unit ramp function. Okay. Now what is unit parabolic function? So another function we can see here. What is unit parabolic function? So in this way, you can draw unit parabolic function. Okay. So equation is given here. So these are all the basic function, and one more important function is that unit impulse function. So what is unit impulse function? Unit impulse function is only defined at t equal to 0, and at all the value except t equal to 0, it will have the 0 value. Okay, so in the form of figure, we can just represent. So this is a unit step function, and it is represented by del of t. So it is defined only at t equal to 0. So now we have studied about the different type of elementary signal: unit step signal, unit ramp, unit parabolic function, and unit impulse function. So I hope that you have studied, you have understood that this elementary signal. Now let us move to the next slide, which is basic operation on signal. So basic operation on signals. Uh, what are the operation on the signal? Means you can either shift the signal, reverse the signal, time scale the signal, amplitude scale the signal. This operation can be done with the signals. So we will learn what is actually time shifting, what is reverse time reversal, time scaling, and amplitude scaling. We will understand this one by one. So let us understand first what is time shifting. So let us understand first what is time shifting. So how we can know? See, to understand the time shifting, let us draw this signal. Okay, and this x of t. Okay, Suppose this is a original signal x of t versus t, okay, and we have to time shift this signal, and uh, I want to shift this signal by unit 2 or by unit 2 second. Okay, so how we can do this? Suppose this is x of t. uh, so suppose if I want, what will the figure or waveform of x of t plus 2? What we have done, what is our original signal? This is our original signal. This is our original signal. Now we want this signal to be shifted by unit 2. So how we can draw x of t plus 2? So to understand this, uh, uh, let us first understand what is t plus 2. T plus 2 means we want to advance the time by unit 2. So if we want to advance the something, then it should come earlier. So let us draw what will be the x of t plus 2. So now suppose this is 2. Okay, this is 0. Here it was 0 only. So this is nothing but your signal shifted by unit 2. Okay, we can see that entire signal it shifted by unit 2. Okay, now this signal has been shifted, or it has been advanced because we have used x of t plus t. Now let us understand, if we want to plot x of t minus 2, what will be the resultant waveform? Okay, so in order to plot x of t minus 2, how we can plot the signal? Let us see. Okay, so this is x of t minus 2. So what is the difference? If we are doing the operation x of t minus 2, it means we are delaying the signal. T minus 2 means we are delaying the signal by unit 2. So delaying means we are shifting the signal to the right hand side of the y-axis. Okay, and by how many unit we are shifting? By unit 2. So we can see here both type of signal. This is called advancing. This is called advancing, and this is called delaying. So shifting can be either advancing or delaying. Okay, based upon the sign of the based upon the how much you are doing the plus or you minus. Okay, so this is all about the time shifting. Now next is time reversal. Okay, so next one is time reversal. So we will try to understand what is time reversal. Okay, so to understand this time reversal, let us draw first the original signal. So here I am drawing here uh, here I am drawing the original signal, right? Now we want to do time reversal operation. So how we can do this? Okay, we should know that time reversal operation is also called the folding operation. How you do the folding? Suppose this is my hand. If I want to fold this hand, we can do like this. This is the folding operation. So in the same manner, if we want to do the time reversal operation on any signal, we will do the folding operation. Like hand I am folding like this. Okay. So how to fold this signal? So suppose this two. Now if I want to do folding operation or time reversal operation, so let us draw the resultant signal. What will be the signal after the folding operation or time reversal operation? So let us draw. Here x of minus t, and it will be, if I'm folding, so it will be minus 2 0. Okay, you can see whatever was at the positive of the time axis, it has now come to the negative of time axis. Okay, previously the lowest value of signal was touching at 2, now it is touching at minus 2. So in this way we can do the folding operation. Now next is time scaling operation. So we will understand what is time scaling. So to understand the time scaling, so let us suppose again I am taking the original signal, which is suppose this is okay. Suppose this is original signal and we want to time scale the signal. Now time scale, if I'm saying that time scaling of the signal, we can do in two way, either compression or expansion. Like suppose if we plot x of 2t, okay, or we can plot x of t minus 2. Okay, so this will be called as compression, and this will be called expansion. If it if I have to plot x of 2t, it means it is the compression. So let us plot what will be value of x of 2t. So let us draw x of 2t t. So if here t is multiplied with 2, so for the x of plotting the x of 2t, we will compress this. It means we will divide the time axis by unit 2. So 2 will be divided by 2, it will be 1 only. So we can plot this signal like this. Okay, so previously it was 2, now it will be 1. Okay, so this is all about the time scaling, and this particular operation x of 2t is a compression. Why I am saying the compression word? Because you can see the original signal is compressed by unit 2, means it has been compressed by 2. Okay, now come to the second one. Let us plot x of t minus 2, x of t minus 2. So let us plot this function also. As it has been stated that x of t minus 2 will be expansion, So how it will be expansion? So original signal will be multiplied by 2. So where there was 2, it will be now 4. So let us draw the original signal, the modified signal like this. So now it will be 4. Okay. Here we can see that this is somewhat expanded. This original signal has been expanded. So this type of operation is called expansion. So we have studied the time scaling can be done in two ways, either in the compression or expansion. Okay. Now, uh, last is amplitude scaling. Okay. So let us move. So amplitude scaling. So what is amplitude scaling? It is very simple. Let us understand. First, we will take some original signal like we have done in the previously. So x of t, x of t, and plus, okay. Suppose the magnitude is 1. So how to do the magnitude scaling? It is very simple. Just this previously what we were doing, we were just scaling the time axis. Now we will scale the amplitude. Suppose now if I want to plot 2 of xt, okay, so it will be simply multiplied. Okay. So these are all about the time amplitude scaling. What is difference in the time scaling? We are doing the operation with the time axis, and in the amplitude scaling, we are doing operation on the magnitude of the signals. So now let us move the next slide. Okay. So today discussion, we have come to end of the today's discussion, and I hope that you have enjoyed this session. And in the next class, we will move to the further. So if you have any queries or any question, so you can leave your query or question in this Google form that I have given here. You can post your query and I will respond of your question for your question. Okay. So thank you for watching.